Example 3 then of equilibrium. So this is the first one where they haven't given us a wee diagram to work from, so we need to come up with our own. So a particle of mass 5 kilograms is suspended in equilibrium by 2 light inextensible strings, which make angles of 30 degrees and 45 degrees with the horizontal. Find the tensions in the strings. So here's what's happening. Say we have a roof up here and there's strings attached to both of those. There's a string coming down here and there's a string coming down here, and attached to that then there's a 5 kilogram mass. So there's a 5 kilogram mass, and we need to think about then what forces we have acting on this 5 kilogram mass. There's forces acting on the ceiling here, there's forces acting all over the place, but we're worried about that. This is an equilibrium. That must mean all the forces cancel each other out, whatever direction they're coming from. So what is holding this in place, suspended in the air? So first of all, with 5 kilograms multiplied by gravity, so that's our 5g. And then, what's holding this in place? Why is it not falling down this way? Well, the 2 strings are holding it, so they then are giving us tensions, and we're going to call that one T1, and we're going to call that one T2. If they were both at the same angle, they would be equal. If you kind of symmetrical shape going on here, but one's at 30 and one's at 45, the horizontal, so we can't quite assume that then. So we need to do and take them differently. So I'm going to do a wee kind of really light wee framework here. You might just be able to see it, and it's going to help me resolve. As ever, everything going this way equals everything going this way, everything going this way equals everything going this way, and we should then be able to try and work out what T1 and T2 are. So first of all, in this direction here, sorry, let's put in our angles. It says it makes 30 and 45, so I'm going to take this one as 30. It wouldn't matter if you did it the other way around. Your T1 then would come out to be my T2, but that's totally fine. They just want the tensions in the strings. So we're going to go T2. I'm resolving this way, so you'll note we're going to cross the 45, so that's cos 45, and that equals T1, so going this way then, cos 30. You'll note the 5g has no effect because it's orthogonal and it's at right angles into that. Going this way then, we're going to have T1 sine 30. I hope we're getting used to this now. We're resolving this direction here. I didn't go across the 30. Plus T2 sine 45 equals 5g, and that acts then straight down. Calling this equation 1, calling this equation 2. We have 2 unknowns here. Sine 30 is just a number, sine 45 just a number, 5g is 5 times 9.8. That's easy, so it's T1 and T2 we need to try and sort out. I'm going to get the T1 on its own here by rearranging this 1 and then subbing it into here. So if I divide both sides in by cos 30, 1 then becomes T1 equals T2 cos 45 all over cos 30. You can have the T2 up on the top line there, that's fine, it's just one and the same thing. And I'm now going to sub into 2. So what does that mean? Anytime I see a T1, I'm going to exchange it for a T2 cos 45 over cos 30. It's a little bit messy, but we should get there. So subbing into 2 then, T2 cos 45 cos 30 times by sine 30 plus T2 sine 45, and then 5 times 9.8 ends up being 49 newtons. You can do this a couple of different ways. This is just a number, you'll get it in your calculator. You want to do cos 45 divided by cos 30 multiplied by sine 30, you'll get a certain amount of T2. This here will give you another certain amount of T2. You add them together and then you divide through, and that would make it work out. You could factorize out a T2 if you wished, but there's no need to do that. Please don't let this confuse you. It's a bit like, year 8 where you have, 2x plus 3x equals 9. And so that means you would have 5x equals 9. It's just we don't have the nice numbers like 2 and 3 here, but they are just numbers. Okay? So if we do our sums for this and work it out, we will get T2 equals 43.9 newtons. Again, try that in your calculator, make sure you're getting the same as me. We now know T2, so if we sub it into number 1, you could sub it into there, it's a wee bit more work, but it's easier if you just sub it in here. So we sub it into here and we will get T1 is equal to 43.9 upon cos 45 over cos 30, and again just a number, plug it into your calculator and you get 35.9 newtons. Hopefully that makes sense.